system that makes it very hard for competitors. And you can always deny that it is political, you can always say that it was a technical reason. So there were technical reasons that made it difficult to support cross-compiling for OS X, and NANOT has circumvented them. So it is now possible to cross-compile, for example, from Syllable Server to OS X, and that's a rather special feature. Well, here's what I talked about earlier. The last on this list is an Intel hex binary format backend, and I believe that is the format that the AVM 8-bit development boards use. So the the small 8-bit Arduino boards, they don't use a complicated toolchain because that would be way too complex for such small embedded boards. So they use a very old, very simple binary format that's called Intel hex. I believe it's 40 years old or something. And that is also fully supported because you need that to generate code for the 8-bit Arduino boards. And it's possible that you also need that for the 32-bit ARM Arduino boards. So that would be a difference between the embedded AVR ARM Arduino boards, which are called the NetDuino boards, and the full ARM backend, which will probably, if you want to run on an ARM Windows mobile platform, Windows Phone platform, you're not allowed to do that by Microsoft because Microsoft wants you to run in the CLR. So to target Windows Mobile, you need to generate CLR code. But if Microsoft would not require that, you would be able to generate ARM code for Windows Mobile. But you would have to do that in the Windows CE format probably. And to run on Android, low level in ARM, you would need to generate ARM code in the ELF format. But to generate ARM code for the NetDuino boards, you probably need to generate that in that very simple old Intel hex format. I'm guessing. So that's a very simple format for small embedded boards. So that is also fully supported because it's a simple format. So that's the red roadmap. How are we doing on video time?
We have 29 minutes.
Okay. Here's the red front page again, and on top is the 0.2.1 release from less than a month ago, I believe. And I think there's a thank word in there with a list of current contributors. If you run sites like Blogger on a small laptop, is it still 13 years old, or is the laptop 14 years old by now?
1998.
Yeah, it's still 13 years. So then you can see which sites are very slow and which ones are okay. In the upper right corner you saw that Red is being developed on GitHub. So it's really set up as a very open source project with the news before that was the Mac OS X port. I think the thank list is further down in the previous release. So the Mac OS X port, a month and a half, 2 months ago.
I thought there was a separate directory of contributors.
Yeah, but it's also in here. It's probably here in the beta release. So only 2 months ago, after half a year of development and only 4 months of public development. See, here are the results of the test suite. And Peter Wood is developing the test suite. And previously he did a test suite for Boron. So
I just saw some contributors.
Yeah, Peter Wood. But here's the test suite by, I thought it said Peter Wood, no, quick test. That's extremely useful because Red is such a new language, and the compiler a language is a very complex thing. Although it's relatively extremely simple written in Rebel, there are still many bugs in there because there are very many cases that you can have in a language. So a test suite is really extremely useful to test for bugs and for regressions when you make changes. So that really helps the quality of the project tremendously. So that is being done by Peter Wood, and Rudolf Meyer is also doing a lot of manual testing. And Rudolf likes to think about language design, so he usually comes up with fundamental questions about the design of the language. Because Red is very heavily Rebel inspired, but it's also very different from Rebel. Especially because Red System is a C-level language. So Red System is really an odd mix between Rebel and C. So it's really a newly designed language. You have features from Rebel and you have features from C. And you have even features from assembler in a portable way. So Red System is really being designed. And the main design is done. And Rudolf has participated a lot in discussing that, which he previously did for Rebel 3, which is also partly redesigned from previous Rebel versions. So a really nice group has come together, who is doing the things that they were already doing. So there's really a lot of experience there, and the design of Red is being done in public. So Nenat is doing the main design of Red, but it's really being helped by contributors, and the testing is really helped by contributors. And Andreas Bolka, he is doing a number of low-level things. He did most of the modifications for the Syllable backend. So Red is running on Syllable thanks to Andreas. And before that he did a large part of the ELF backend to make it run on Linux. So the first step was to make it run on Linux, and then it was another relatively small step to adapt it to Syllable. So Andreas did a lot of that. And he is now working on one of those ARM backends. And I believe he is working on one of the newer ARM CPUs that you would find in netbooks, for example. So I think Nenad is working on small ARMs, and Andreas is currently working on the bigger ARMs. And of course, myself, I always wanted to get Rebel on Syllable. And last year we got Rebel 3 on Syllable. So now I'm working with the other ones to get Red on Syllable. And I'm now working on the bindings with all the libraries that we're using in Syllable. Yeah.
Red system is not object-oriented, I guess?
No, Rebel is not object-oriented, although partly. Rebel is literally the relative expression-based object language. So it uses objects, and in a way it's also mostly based on objects, because every Rebel function is implemented in an underlying object. And an object in Rebel is usually called a context. It's a namespace. So in Rebel an object is not so much seen as an object, but it is seen as a namespace, a context. And because a function is a local namespace with local variables, each Rebel function is implemented in an object, in a context. But you can also do much more with contexts, but they're also used to implement functions. And because Rebel is mostly a functional language, and all functions are implemented on objects, Rebel is largely an object language, that's why it's called Rebel, but it is not a pure object language, because in pure object languages every data item is an object. An integer is an object, a string is an object, and that is not the case in Rebel. In Rebel, an object is just one of many data structures. And specifically, an object is the data structure that implements a context, a namespace. So objects are very important in Rebel, but they're not exclusive. Not everything is an object. Simple data types such as integers and strings and URLs and email addresses, which are special Rebel data types, they're not objects because there are more efficient data types for them. And Red is the same, your original question. Red aims to be as compatible to Rebel as possible. So Red will basically also be an object language based on contexts, but Red system is a low-level C-style language. And C doesn't have objects, and C doesn't have namespaces in the way that Rebel has them. A Red system has namespaces for functions, because functions need to have local variables, but functions in Red systems are not implemented on top of objects because there are no objects in Red system, just like in C. But Red will have contexts, so Red will have objects, and that means that Red functions will also be implemented on top of Red objects, just like in Rebel. Does that answer your question? Okay. Well, we should get back to the rest of the program for today. So this was our RebelCon conference in February, the first Rebel conference in a number of years, which is now followed up by similar conferences in France. So we set a nice new trend with that, and Red was introduced there, so we're very proud of that. But now to our current Silcon. I was on our own website to look for the link. Oh yeah, I have it in the other browser. Back to our program for today. This was the overview story for Red, and as I said, early January 1, we were thinking that we would be continuing our developments this year and trying to make things more public. And we had a preview of the new Syllable Desktop Live CD both on the Silcon in January and on the RebberCon in February, where we had a second preview. And after that, I've finished the new live CD and I've released it on the internet. So since a few months we have a new live CD, which is now nicely being downloaded due to the interview on Tech World and the publication on the publicity on Slashdot this week. So that was the last Syllable Desktop release this year. So that makes things more public. And that was actually the first live CD in 3.5 years, because we still had the 064 live CD. And the story about that is that the live CD was made by a contributor a long time ago, and the live CD was always his project, and I helped with that, so I had insight into how the live CD worked, but I had never actually built one myself. And 3 years ago this contributor left the project. So since then there had been no new live CDs, because we didn't have time for the extra load. So we were still on the last Syllable 064 live CD. And this is a live CD of Syllable 066. And this is a new series of live CDs, because I had to build a new one from scratch, because we didn't get the build scripts from this old contributor. And while I was making the new live CD from a bare Syllable 066 installation, I found out that it didn't work properly without a modification to the init process, the first process that is started by the Syllable kernel, that continues to start other processes, and eventually the app server and the media server. And this is the init process is written in C, just like in most Unix systems. And the live CD runs its most important early parts from a RAM disk, because some parts of the system do not like that they can't write to the CD. If you run the system entirely from a CD, you get lots of errors, because Syllable assumes that it can change certain parts of the system, such as your home directory and maybe certain parts of the configuration. So it must be able to write to the home directory and to have certain configurations. It must be able to write to the configuration files. And there are two sorts of configuration files in Syllable. There are Syllable's own native configuration files, and there are configuration files that are inherited from third-party ported packages, and those are simply in the old in the old Unix directories. So we have Syllable's own configuration files, and we have the legacy third-party configuration files in the etc. directory. And if those can't be changed, then there are certain things that you can't do, such as setting the screen to the resolution of your computer. The app server starts with the lowest resolution, and if you want to change that, you have to change the app server configuration. And you can only do that if the configuration is writable, because Syllable was not designed to run from a read-only medium. So what you have to do is you have to identify the parts that need to be written to, and then you need to copy those into a small RAM disk that will take some of your memory away. So the live CD needs more memory than a Syllable installation. And you have to transfer those parts to the RAM disk very early in the startup process. And it turned out that the init process that starts the system right after the kernel did not do this at an early enough stage. So there was a patch for that that is on the 064 live CD, the old one. And in hindsight, I remember that Christian programmed that modification for the creator of the live CD, but that code turned out not to be in Syllable. So we lost the build scripts of the live CD, and we also lost this modification to the Syllable init process. So I had to analyze that and recreate it so that the RAM disk could be initialized early enough. In fact, the point is, it needs to be initialized before the app server starts, because you need to modify the configuration of the app server to be able to set a higher video resolution and things like that, and the keyboard setting and the language maybe of the app server. You can't do that if the app server configuration is read-only. So I recreated that modification to the Syllable init process, and I made a new build procedure for the live CD, and it was constructed from a bare Syllable 066 installation CD. So there were a few important things I needed to do to build a new live CD, and then there are always lots of details that you need to straighten out to get everything right. So we had a pre-release at the SillCon in January, and another pre-release at the RubberCon in February, and now we have a public release of a new live CD, the first one in 3.5 years. So that's one of the things we did to make stuff better available to the public, like we promised January 1. But on the other hand, as I was telling, in February it turned out that we got a whole new Rebel-inspired language, Red. So instead of the planned development, that most of which I was planning to do for Rebel 3, I have now shifted almost all of those plans to Red instead, because Red is fully open source instead of only half like Rebel 3. Therefore we have much more control over it. So if there are problems in porting it to Syllable, we're not stuck. We don't have to wait for Rebel to do that. So we actually, with about 3 people, we did the port of Red to Syllable, and that's not something we can do with Rebel. And the added fact that Red is much more low level, certainly Red system is much more low level than Rebel, and that fits an operating system even better than Rebel does. Rebel is already designed by an operating system designer, by Carl Sassenrath, the chief designer of the great Amiga operating system of yore. But because Red is much more low level and compiled, it's even more suitable for operating system development. So many things that I was planning to do for Rebel 3 can be done at least as well with Red, and there are also many more things that can be done with red than could possibly be done with Rebel 3. So I've basically shifted all my plans to red after I saw that it was developing so well, and as you said, the plan is extremely ambitious. You have to wait if that's really going to happen, but after half a year we must conclude that red at the moment it's maybe 1 month behind on the original time plan, and that is really extremely good for such an ambitious planning. So it's really developing very well and very fast. And of course there was the question if it could be made to run on Syllable Desktop, because that is a requirement for me to start with software. And we did that in the past half year. It's running pretty well on Syllable Desktop now, so red is really suitable to shift a lot of plans to. On the other hand, that means that the past half year and the rest of the year I have and will be so busy with red that a few of the other things I was planning to make syllable development more visible this year have been postponed because red work is now more important. But at least we did the new live CD, and the year isn't over yet, so we will try to do a few more public things about Syllable in the rest of the year. But also the red work is immediately usable, and we will publish that in parts as it happens.
7 minuten.
7 minutes left on the video, so I'll go through the rest of the program. And then when I start to show stuff, we'll have to think of a way to get that on tape too. I hope we will succeed in that. Several of the next points I've already mentioned. Cross-development, and at this moment particularly from Syllable Server to Syllable Desktop, that is enabled by red. Of course, it's possible to install a cross-development environment with the GNU toolchain to compile from one system to another. That is extremely complex and extremely heavy weight, and it's one of the classic problems in computer technology to cross-compile. And so in Syllable, we, contrary to many other alternative platforms, most other alternative platforms are cross-developed from Windows or from Linux, or maybe even from BOS. But Syllable was already self-hosting when we got Atheos. Atheos was also already self-hosting, and that means that you can compile the system on itself. And that means that we never really supported cross-development because Syllable could already compile itself, and so we could compile Syllable programs on Syllable. Hey!
Hey, welcome.
Oh, hoe is die?
Ja, goed.
Je hebt net ons publiek verdubbeld, hoe raar.
Ja, net ja. Ja. Ja.
Do you mind if we keep the conference in English?
Yes. No, I don't mind.
Okay, we have another visitor. Welcome. I'm going to hurry a bit because we have about 5 minutes of video left in this batch. So I'm showing here the program for today, and I'm walking through it. I've just told a lot about Red, our new Rebel-inspired programming language that we're helping to develop. And one of the very important things that Red enables is cross-development. And now, after only half a year of Red development, we're able to cross-compile programs from Syllable Server to Syllable Desktop. And in the rest of the afternoon I will show several of the programs that I've done in Red with bindings to external libraries that we use in Syllable. And those programs are developed on Syllable Server and cross-compiled from Syllable Server, and then you can copy them to Syllable Desktop and run them there without doing any development or cross-compilation on Syllable Desktop. And I was just telling that this is fundamentally different from how we've always worked in Syllable, because Syllable is self-hosting, so we always used Syllable itself to compile itself and to compile Syllable programs. And with Red, it is now gradually becoming possible to develop Syllable programs on other systems, such as Syllable Server. And probably by the end of the year, Red will be bootstrapped from Rebel to Red itself. And at that time, we will be able to run Red itself on Syllable Desktop. And then we will be able to develop on Syllable Desktop for other systems such as Linux, Windows, Mac OS, and embedded development boards such as ARM CPUs, Arduino boards, and very small Arduino boards with AVR Atmel 8-bit CPUs. So that's all pretty exciting, and it really extends what we can do with Syllable. And the nicest thing about it is that it's doing it in a very anti-complex, I would say, way. The whole Red system is incredibly smaller than the GNU compiler toolchain that you would otherwise have to use to do such things. Okay, so it's Red that is developing, that is enabling cross-development for us now. As I said, the past half year I'm really focusing on writing Red system bindings for libraries that are in Syllable, and I've done 5 of them now. Some of them are not ported to Syllable Desktop yet. One of them is 0MQ. 0MQ is a relatively young messaging system. And as you know, Syllable is based on a messaging system like BOS and Amiga. But the interesting thing about 0MQ is that it's cross-network. It can message over networks, and that's also its main purpose. But it's also quite like the Syllable concept of messaging. You can also use it to message within one application, between threads, for example. So you can message between threads, and you can also message over the network, and you can do that without changing your program. So the very interesting thing about 0MQ is that it extends the Syllable concept of messaging on which the system is built over networks. And you can do it without changing your program, just a few of the configurations if you want to make your program work across networks. So it's a bit like when you run X11 remotely, that you display an X11 program that is running on another computer on your local desktop. And that is built on networking transparent technology. And if you build your programs on 0MQ, you will have similar network transparent capability. And that's also something that was more or less planned for the Syllable app server. The Syllable app server could be made network transparent by making Syllable messaging network transparent. And that has never happened, but it could be done. And similar things can be done with 0MQ. And at the moment we're using it on Syllable Server, but I haven't been able to port it to Syllable Desktop